Hey, welcome back to Math with Patrick. Today is January 6th, and we have yet another math problem to solve from that Daily Epsilon calendar. Looks like what I need to show is that this number right here is secretly just a 6 all along. So let's get into it. Let me write the problem horizontally right now, just because this vertical math, I don't know, it doesn't look normal to me. So I'll just rewrite the problem to start out. And one thing that I'd like to do is just get all of this under one big ol' square root, then solve for whatever is in here, and knowing that the answer is 6, hopefully I can get a 36 out of it. So, and that's just because I know that the square root of 36 is 6. So that's my goal, but I need to show that I can create a 36 out of this. I also need to show that I can stick them underneath the same square root. So I'll do that part first. I'm going to claim that I can take the square root of a product and make it a product of square roots. And let's actually take the square root of 36 as the example. I know that 36 is the same thing as 4 times 9. And what I want to show is that if I split up the square root of 36 into the square root of 4 times the square root of 9, it's still going to be the same. Thinking about it as just like the definition of a square root, I know that I can find some number, 6, multiplied by itself, and that gets me 36. Then thinking about this step of splitting it up, I could show that this is a 2, because 2 times 2 is 4. And this is a 3, because 3 times 3 is 9. And ultimately, 2 times 3 also gets 6. So the whole point of this was just to show that I could split up a square root into its products. I could also go backwards, and that's what's going to happen here. I want to shove both of these square roots together under one square root sign. So what I showed with the example has a name. It's called the product property of square roots. And it just means that I can take the product of two square roots and write it as the square root of a product. So I'll stick the first part here and the second part here. And currently what I see is that I have two binomials multiplied by each other. And so there's a few different ways to think about it. You could use the distributive property, or you could use an area model, or you could use something called foiling, where you multiply the first, outside, inside, and last terms. I think I'll just use an area model. I like doing that when I'm multiplying polynomials. So I'll draw my box. I'll label one side with a 7 plus root 13, the other side with a 7 minus root 13, and I'll multiply to get the 4 terms on the inside of this box. So 7 times 7 is 49. These two together I'll just call 7 times root 13. These two make a negative 7 root 13. And these two together will make negative 13. Now that I found all 4 of these terms, I just need to add them all up to get my whole product. So fortunately, I noticed that this 7 root 13 and negative 7 root 13 cancel. And so I'm just left with the square root of 49 minus 13. Now that subtraction isn't too hard. 49 minus 13 is just 36. And there's that 36 that I was hoping for from the start. I know that 6 times 6 is 36. So going backwards, the square root of 36 is just 6. Thanks for tuning in to another episode of Math with Patrick, and I'll see you tomorrow.